And this is kind of where this class is going to get a little more challenging, okay? So please try not to miss class. All right, how are we finding critical numbers? Let's do part A. How are we going to find the critical numbers? On the graph we can see, but when we get these new numerical problems, how do you find the critical numbers? What did we just say? So the critical numbers, do we just say, occurs where what? The derivative is equal to 0 or the derivative does not exist. So if they ever ask you to find critical numbers and you're not given the graph, you have to take the derivative. So everything that we have done before is coming back right now. So to find the critical numbers here, we're going to take the derivative. So what's g prime of x? Someone help me with this.
3x squared minus 12.
3x squared minus 12. Right? And we know the critical numbers is where f prime of x is equal to 0 or f prime of x does not exist. And we don't need to worry about the does not exist part here. Why not?
Because it's not a fraction.
Because it's not a fraction, so we don't need to worry about this. Right? So we have to set it equal to 0. And there's multiple ways of solving this, right? We could bring over the 12. We have 3x squared is equal to 12. We divide by 3. X squared is equal to 4. So what is our critical numbers?
Positive and negative 4.
Very positive and negative 2, right? So this has two solutions. We can use the square root property, which we know that gives us x is equal to plus or minus the square root of 4. So x is equal to plus or minus 2. If not, you can factor it. You can use a quadratic formula because this is a quadratic equation. So these are critical numbers. So what do we want to do now? We're going to set up our table. So our intervals will be from negative infinity to negative 2. And we're from negative 2 to 2. And from 2 to infinity. So if you think about this, this is like our number line. Our critical numbers is at negative 2 and 2, right? So this is how we're getting our intervals. These are the critical numbers. Critical numbers. So from here, this is negative infinity to negative 2. Then we have from negative 2 to 2. And then we have from 2 to infinity. So this is how we're getting the interval. So if you think about the terms of a number line, you probably see that a little clearer. Now we're going to choose some test point. We have to choose test point in the interval. So here we could choose negative 3. We can choose 0, and we could choose 3. Now, if you recall, what did we do above? We have to take those test points and plug them into the derivative. So we're going to find f prime of negative 3. We're going to find f prime of 0. We're going to find f prime of 3. And our derivative, once again, was 3x squared minus 12. That's where we're plugging it in. Sure. So Louis, think of a number in this region here. What's a number between negative infinity and negative 2? Is 0 in between negative infinity and negative 2? You sure about that? This is from negative infinity to negative 2, right? So choose a number over there. Right? So it could be negative 3, negative 4, negative 5, right? That's what we're doing. So that's how we came up with this test. And here, choose one in here. So we just choose 0. And then we're going to choose 1 over here, which we choose to be 3. So, very good. Yeah. So now we have to do what? We're finding f prime of 3, which is going to be 3. What is it? X squared minus 12. So this is going to be 3 times 0 squared minus 12. And this is going to be 3 times 3 squared minus 12. Did anyone get any answers for this?
15.
15 for the first one?
Mm-hmm.
And this one?
Negative 12.
And this one?
15.
Okay. So when we find this, what we're really finding is the slope, right? And from the slope, we can conclude if the slope is positive, is the graph increasing or decreasing?
Increasing.
It's increasing. So this graph is going up like this. This isn't decreasing, so it's going down like this. This is increasing, so it's going up like that. So that tells us that at negative 2 right here, this is a relative max. And down here, this is a relative min. So we have a relative max at negative 2 and a relative min at 2. We still need to find them. We need to find a y value. Oh, it's time to go. I didn't realize it was so late. So we know we have a relative max at negative 2, and we need a relative min at 2, and we need to calculate the y values, and that would be our answer. And how do we find the y values? We're going to find f of negative 2. That's how you find the y values, and we're going to plug it in here. We're going to find f of 2, plug it in here. All right, sorry I ran 2 minutes over. If you guys have any questions, let me know.